Hello. Welcome back from the break. We're going to start having our final round of speakers, and I would like to introduce David Greenspan, who is going to talk about Meteor. He's actually from Meteor, which is cool, and he's going to talk about it. So here you go.
Hello. How many people here have heard of Meteor? Cool, cool. Okay, awesome. I am David. Who am I? I created Etherpad, or I co-created it. This was like collaborative Google Docs before Google Docs was very collaborative. We sold it to Google, who then decided they had enough collaborative editing projects on the go, so they open sourced it. You'll now find various things called this pad or that pad, like HackPad, around the internet. So that's kind of the code base living on is open source. While I was at Google, I worked on Google Wave and Google App Engine. And then I joined Meteor to be basically employee number one after the three founders. What is Meteor? Meteor is an open source full stack JavaScript framework for the next generation of web apps. It's also a venture-backed company, 6 engineers and growing, funded by Andreessen Horowitz and Matrix Ventures. And it's a burgeoning community of web developers who are excited about our new tools. So why Meteor? What's our value proposition here? It's that apps are too hard to write. They take too many people, too much time. Even like, these apps, Gmail, Google Docs, Quora, Pinterest, people type in text, the text eventually gets displayed back. This is not rocket science, right? Like, there's some querying going on, there's some searching maybe somewhere, some indexing, and data gets munged and aggregated. But these products take teams of 20 to 200 engineers, and I won't say which ones take 200 engineers, but some of them probably more. But basically, you need 20 really solid people to pull off something like this in today's world. But these companies don't just write spaghetti code, they actually develop in-house frameworks. Facebook has their own framework, Google has their own framework. Sometimes you hear about them, sometimes you don't. Sometimes if you don't hear about their in-house frameworks, it's not because they're trying to keep them secret. They just don't allocate the resources to extricate it from the rest of their code, generalize it, package it up, document it, get it past the legal team who's always worried about liability if some page of code turns out to be GPL later or something. But these companies are doing really cool things. Google+, the Facebook page now is very live. It updates, it has chat, it has a zillion things, it loads very fast. How do they do it? Well, there are these principles that we've kind of abstracted from our experience at these companies and making apps. One is that there's JSON on the wire, not HTML. Maybe you get some HTML initially as a performance optimization, basically. You might want to serve a rendered page. But then you get updates in the form of JSON objects, and you probably want these to stream down a socket. They might be new objects. They might be representations of updates to existing objects, basically data diffs. You have some sort of managed client-side database cache, meaning you have some subset of the database on the client. This happens basically when you start making an app like Gmail or Wave, or even a photo album. You don't want to hit the server every time the user clicks. You don't want to hit the server per, say, photo in the album. You probably want to assemble a local database of maybe records for all the images in the current album, even if you've got a paginated album. You might even want to download the thumbnails, or you might want to subscribe to, say, all the thumbnails in the previous page and the next page. So you've got limited RAM on the client. You've got limited bandwidth sometimes, especially on mobile, but you need to strike some balance that differs between applications of what do you go to the server for and what do you want to already have sitting there. Maybe you bundle it up in a blob and you send it down and you get 100K of stuff and you put it in RAM or you put it in local storage or something. And finally, views are rendered on the client based on the cached model. And if you're really clever, you can render views on the client and the server, render the same views. Facebook does this now. Google+ doesn't. It just builds the whole page on the client. But either way, even if your backend is SQL, you probably turn a row of your SQL database into JSON, send it down to the client, and then you feed that into a handlebars template or a Jade template or something if you're doing things in this model. So let's look at, how do you write an app? It's 2005. Ajax has just been coined. It's very exciting. We have JSON. It's, Yahoo now supports JSON in their APIs. Google doesn't until 2006. So JSON's kind of new. When someone clicks a button, you send something to the server. It might be XML. It might be JSON. It might be just a post. We don't really know, but it's going over XHR probably. We get something back. It could be success code. It could be a JSON object. It could be XML. It could be, here's some HTML that you should spray somewhere into the DOM that you know about somehow. And then you do something to fix up the DOM, which is either a setting inner HTML, you run some jQuery, or maybe some Moo tools or some prototype or something. It could be that you take HTML off the wire and you put it somewhere, or it could be that you the message on the wire is this post just got another like, update the count. So then you go and you run some selector, you find the count, you set inner HTML on a span or something like that. The new model that is really just kind of dawning on the web landscape, and it's being independently reinvented in different places, is the user clicks a button, you send a JSON message to the server, and then you're done because you have the stream set up where any changes from the database are always coming down. And then you also have some sort of bindings or reactive system so that when the views should change, the views change. And it could be scoped as small as a certain span is registered as a listener, either implicitly or explicitly on a certain piece of data. So somehow you want the views to automatically re-render. And if you can achieve that, then you've really got a great system where you don't have to write a lot of the code that does this right now. So I'm not going to talk as much about the data model stuff today because I'm talking about view stuff, but this is the first half and of what Meteor does for you basically. And there's some really cool stuff here you should check out. But the ingredients are you've got WebSockets or some kind of fake WebSockets, which WebSockets don't really work yet. They don't work on mobile. They don't work on IE, or at least old IE. They don't always work through proxies, even though they're supposed to be designed to. So often you end up in long polling territory. We called this Comet back in the day. I don't know what happened to the term Comet, but we have a special protocol called DDP, which is for streaming APIs. So instead of a REST endpoint, you say, I want to subscribe to this set of data. Tell me when an object enters or leaves this set. Tell me when a property on one of those objects changes. And it also integrates with RPCs and subscribe, unsubscribe requests from the client. So you get some really lightweight synchronization semantics that are really good. Client-side mini databases is the idea that if you're going to have some cache on the client, why not give it the same API you use on the server? So if you use SQL on the server, we will give you some sort of mini SQL, which it might be implemented in RAM or in something like IndexedDB. But ideally, you can write the same code on the client and the server to update your model against some sort of SQL binding or Redis binding or Mongo binding. And that allows us to do something even fancier, which is to simulate basically all the business logic on the client, run it on the server too, and then see what happens on the server, because the server is allowed to reject it. It can say you're a hacker trying to hack in from the console. It can say you're not authenticated. This doesn't validate. And if the server disagrees, the server will send down its diff, and then the client just patches up the database and magically morphs the UI into what it should be. So if your change is denied, it'll just go away. Or if something different happens because the backend can talk to Twilio and the client can't, then that extra information will come down the pipe and everything will just reconcile. The other half of this is how do you, okay, you have this magic updating database on the client. How do you update the DOM? How do you somehow observe those changes and fix up the DOM? I dug this code out of Etherpad for this talk. I find it fascinating how much code I came up with to, but what this does is there's a preference checkbox that says, should the sidebar be visible or hidden? And when you toggle the checkbox, it toggles the sidebar. And it does this by toggling a class on the body. In the middle there, there's a toggle class on the body. There's also a lot of other code in here because there's other considerations. There's a cookie preference that will save whether you like to have the sidebar or not. And that works even if you're not logged into Etherpad as a user. There is some sort of communication with the server that's not shown here to kind of save your individual preferences. And what you can see here is stuff like setting classes on the checkbox. There's this pad.determine sidebar visibility, which must be called from a couple other places. When do you determine the sidebar visibility? I don't know. I'm showing you really ugly code here. But this was the result of starting with a reasonable abstraction that I want to plumb the checkbox to the server and to the screen, and then all these other considerations came into play, and I ended up with having a cancelable action where I can defer setting a class on an object and then maybe cancel it if something else happens. And it's actually the right idea. It's the right kind of pattern, but without a framework, you just end up with 30 lines of code for something that you don't want 30 lines of code for. So what do we do? Callbacks, bindings, observers, controllers. There are a lot of words for this. There's different, Backbone has a way to do this. Angular has a way to do this. But we think it's not very automatic if you have to write the update code, if you have to actually listen for that observer, if you have to actually do something. So our solution is declarative views. And we actually heard the same term at Facebook this week when we were giving a tech talk there. They somehow had this similar thought, which is don't write less update code, write no update code. And if there's one thing I pitch you on today, I want it to be that, think about if you can write your templates once and then never update them by just rerunning the appropriate code. Facebook has now does this for their comment box. There's this little box that appears on different places in the website that just has the text area, comment, and like or something. And everywhere that box appears, it actually is driven in this way where they just wrote what the HTML should be in each state based on some JSON object. And then they did whatever they had to patch it up. And they have an internal framework for this now that they're going to use on more and more of their site. So they don't have to write this update code, and they're saying, yeah, the diffs are great because I'm committing to the UI code base, and it says I removed like 100 lines today, and I wrote 10, and so it's just really great. So I want to get to the demo quickly so I don't run out of time. But a template is a function that generates HTML, as far as we're concerned. If the template accesses model data, and that data later changes, what we want to happen is the template is rerun, and then the DOM is updated in place wherever that template ended up on the screen. So a template here might be a subview in some hierarchical view. It could be, on your blog page, the blog post is a template. Each comment is another template. Maybe even like showing a user with their avatar icon next to them. There's a template for that. So I'm going to do some live coding for you here. Actually, I don't need internet, so this is good. I'm going to type Meteor create cool demo. Gives me a little bit of scaffolding. It doesn't actually give me a cool demo just for typing that. That would be nice. So it's not a lot of scaffolding. There's 3 files. Cooldemo.css is literally just a comment saying put your CSS declarations here. I can run this now. I can say Meteor. So there's my app. That button doesn't look very good. I'm actually going to even make this app smaller and just cut out some of the boilerplate it gave me here. JS file. Kill a bunch of this stuff. So this JavaScript file is run on the client and the server. I can ask if it's currently the client or the server where it's running, and I can also put code in different directories, but I'm not doing that here. So what I'm going to build for you is something that has a clock. I'm going to say Meteor startup. Oh, the other thing to note here is that this updates live. If I were to say hello here and save the file, it reloads the app. So this is one of our nice kind of developer niceties. I'm going to say set interval. So this code's going to run every second. And it's going to set a session variable, which is kind of like a client local key value store. It's going to set time to a time string. So now this code is already running. If I say session.getTime, no, it's not. What did I do? I said get instead of set. So now the time is actually being updated by that timer. If I want to put it in the DOM, I write a helper. And helper called time does not mean go to the session variable. It just means call template.main.time, which is a function. This might look even cooler in CoffeeScript, I don't know. And this will return session.getTime. And it's actually updating live, even though I didn't write any update logic. All I did was I set the time in a session variable, and somehow it knew to go to the DOM. I'm going to put this in H2, make it a little bit bigger. So interestingly, if I call template.main, I get a string, and that's not updating, which it couldn't. It's a string, it's immutable. But if I say document.body.append child meteor.render of the template, oops, I need more room. I actually just added a document fragment to the DOM, and it's updating too, which is kind of cool. If I look at my DOM inspector, there really are just 4 DOM nodes here. You can see they're all being swapped out, because if I click on one, I can't stay selected on it. Oh. Oh. Where should it be over here? Is that better? Does that work? Okay. Make this a little smaller again. I can also, if I put an input field in here, that input field is not being updated. So obviously this template replacement is really just scoped to this H1 and this H2 somehow, because those are the ones that are in this template, and the re-rendering happens at a template level. I could also say, oh, it kind of sucks that if I select part of this text, I lose my selection when it gets replaced. I can do that. I can, so it's Meteor Spark that has these features, like I can wrap hello in, well, that's constant, that shouldn't be changing. Now if I select part of hello, select part of world, oh, I'm out of luck. If I select the whole thing, the selection actually jumps to just hello, because that part is not changing. I could also say, oh, this H2, like I keep losing it. I really just want to replace the contents. And there's a directive for this, template.main.preserve H2. And now the H2 is actually still there, and it's only the text node inside it that's being changed. I can take this a step further and say, let's put the input field in the template. Let's give it an ID, and let's have its value be the time. So now my field is ticking away here. And if I type in this field, it temporarily stops updating, which sometimes is what you want. Sometimes it's not. You can actually customize this behavior. And then as soon as I blur it, it goes back to updating from the database. So it's not clear how this works from the demo, but it's clear that there's a lot of interesting magic going on. And it's plain HTML. Like I could style this with CSS. The elements could obviously be anything I want, and I can have nested templates. The goal is also for this this is handlebars I'm using here, but this is supposed to work with Jade, basically work with anything you want. So we had to engineer the underlying technology in a way that would make that possible. I'm going to try one more stunt here, which is style, position, relative. The left is going to be foo ems. And I'm going to define foo to be the time. I'm going to make it the 7th character, which should be the 2nd digit. So now this is jumping around. But if I select part of it, it's actually still selected. All it's doing is patching the property in place. So you can imagine all sorts of uses for that. If it's not just obvious from seeing something jump across the screen. Okay, so, huh? Can you do the blink tag too? Yes, this officially deprecates the blink tag now. So with my remaining time, I'm going to say how this works, or try to. This is a comment from the top of one of our source files. This is our founder, Jeff, in the early days of Meteor. Said, stand back, I'm going to try science, which is what he says when he's about to come up with some computer science primitive that can live in a little black box and just do exactly what you want. So this first black box is actually a pretty small one. It's our dependency library, which I think we say on our website something like, this is 75 lines, and it runs all the dependency invalidation for Meteor. It's like our reactivity framework. But it's actually pretty lightweight. So each template creates a dependency context, call it C, and it calculates the HTML in that context. And the context is basically, there's this dynamic variable or thread local or on the stack variable kind of. If you create a new Meteor Deps context, you call run with a function. It calls that function with that context in the current context variable. It runs the function, and then it takes away the context. And you can nest these. They're kind of like specials in Lisp or dynamic variables in various languages. You can nest these. There's always some current context active, or the current context might be null if you're not inside any of these calls. And the reason you would want there to be this kind of almost global variable that's what's the current context is on the data source end. So this would be in the implementation of session. This is all stuff you actually don't see as an app developer usually, unless you're creating a data source or implementing a template language or something like that. But inside the code to session, what it's doing is saying, OK, someone just said get the time. I'm going to look at what the context is now, save that away, and the next time the time changes, I'm going to go and validate that context, and whatever other contexts also try to access this session variable. This is harder to show in code, but basically, in something like session.get, you would say, what is meteor.deps.context.current? You'd save it somewhere, and we have some helpers for this to keep like a set of active contexts. And then later, when the data changes, you call invalidate, which what that should do somehow is rerun the template for one thing, and also patch it into the DOM, so that the context kind of like knits together the function based on where it was called, and the DOM based on where the string ended up. So that's kind of funny. Like, how do we know? We know we're in string land. We're running our template language engine. And these engines, they kind of work the way PHP does. They might even, intermingle code and presentation stuff. So you've got some HTML string buffer, and every time you say something, it goes into that buffer. Every time you do one of these mustache directives or something, it runs a function. It puts that in the buffer. All Spark can really do is it can look at these strings going by and say, OK, I want to be able to find this later. So we have this annotation system where when things end up in the DOM, I was going to say that what makes this tricky is that HTML is complicated, and the sites we make are complicated. They have all this hierarchy. People using different template languages that generate strings and then just use string concatenation to build up a whole page, which is what you want to do because you want to be able to run it on the server. It sucks when you lose the ability to run your templates on the server because you're, say, just building them all in jQuery using create a fragment and insert it. It'd be nice if your page boiled down to here's the HTML, but as you're generating it on the client, you want to mark it up kind of. So we have these things called live ranges, which are basically like virtual elements. They don't show up in the DOM inspector, but they invisibly annotate the DOM. And that's what was wrapped around that H1 and that H2 that we're changing in isolation. There is this data structure behind the scenes. And it's also what we use for event binding, which is basically like $.live in jQuery. It's live events. And data binding, you can literally say, take this string of HTML. If anyone later asks what data object is associated with any of these nodes, it's this one. And I don't know where this string is going to go, but wherever it goes on the page, this is the data object to associate with it. So, say you have a bunch of table rows, and when someone clicks on one, well, what object is that? You can generate the string that's the TR tag, basically, wrap it in this annotation, shove it into your string buffer, and Spark will parse out all the annotations, turn it into DOM for you, put it in a document fragment, and then wire up these annotations so that you can later inspect them. You can replace parts of the DOM that you've wrapped. So Spark it consists of dependencies, deps.js, which is really just a core Meteor file, but Spark depends on it, and it's small. Live ranges, which are these kind of virtual DOM nodes. And then there's all this fancy stuff that I demoed a little bit, but don't have time to explain in detail. But it's stuff like preserving input fields. That's actually done with kind of a diff patch, where you specify what preservations to try to do, and it will calculate a patch on the fly by walking the existing DOM and the new DOM and doing something smart. You can also have it patch around widgets like Google Maps, D3, stuff that does its own DOM manipulation. There's template matching, which means even if you are forced to re-render a whole table or a whole part of the page, it will actually figure out what template calls from last time correspond to the template calls from this time. And it'll do it before it even calls your template. So your template can access literally like kind of state in an object that you set up associated with the template. Even if it has to re-render the template, you get this extra layer of, maybe the user won't even notice because we're patching and we're copying the old state data over. And what this means is, you don't have to think about this stuff quite as much as you write your app. But you always have control over it. It's customizable. You can get notifications when parts of the screen are updated. And it just gives you this nice leniency where, it's bad if too much of the screen gets re-rendered for performance reasons. But you can definitely put that off for a couple weeks. It's also bad if you find that your input field is getting replaced and you're losing the user's typing state. But there's basically ways to do that too. So yeah, you basically, you write your templates once and it handles the rest for you. And if it doesn't seem to be doing the right thing, you can tune it and steer it in the right direction. And worst case, you end up with a few extra node creations or things that are slightly less efficient. But then you can kind of pick your battles in that sense and not pay a tax in terms of developer time. So you can use this today. We don't advertise that you can run it without Meteor, but you can. We have a wiki page on GitHub about it. It's 10K gzipped with all its dependencies, including deps. It doesn't depend on the Meteor data socket stuff. It doesn't depend on the server-side stuff. It runs in IE 8+ without jQuery, and IE 7. It'll use jQuery or Sizzle if it finds them in the global namespace. And failing that, think about declarative views and whether you can write your templates once and not write any update logic for your particular application.